Okay, so this is the key for quiz 3. This would be problem number 1. Problem number 1 asks you to do 3 things. It asks you to provide the number of stereoisomers possible for the structure. It asks you to draw an enantiomer of the structure. Notice my grammar here. I said an enantiomer. How many enantiomers are there? There's just one. So you should have read this as draw the enantiomer. There's only one. And then the other thing it asks you to do is assign R and S to any chiral centers in the molecule. So that actually is something you have to do anyway. So the number of stereoisomers, this is going to be equal to 2 to the n plus m, as a lot of you wrote on the quiz. So n is the number of chiral centers, and m is the number of isomerizable double bonds. I think a lot of people thought that m was equal to 1. So let's look at that. First of all, let's put a star next to any chiral center. Okay, so this carbon here is bonded to a nitrogen, hydrogen not shown, an sp2 carbon, and an sp3 carbon. That's 4 different things. That's a chiral center. This carbon is bonded to an oxygen, hydrogen not shown, a carbon that has no hydrogen, a carbon that has 1 hydrogen. That's 4 different things. So this is a chiral center. This carbon is bonded to 2 methyls. The methyls are identical, so that is not a chiral center. Don't let the wedges and dashes fool you. That's an sp2 carbon. It's bonded to 1, 2, 3 different things, not 4. sp2 carbons cannot be chiral, so these 2 carbons cannot be chiral. Most people got that. This methyl group, 3 hydrogens on the carbon, it's not chiral. Bromine's a single atom. So these are the only 2 chiral centers. So 2 chiral centers. And then the big question is that an isomerizable double bond? And it's not. It could be. I mean, it's obviously each carbon. So this sp2 carbon has an sp3 carbon and a bromine. Those are 2 different things. This carbon has a methyl and a CH, 2 different things. But you can't isomerize that. That double bond cannot isomerize to be, well, it would have to go from, it's an E double bond right now, so it would have to go to Z, but it can't do that, because if you isomerize about that, you can't make the ring. So double bonds in rings, cannot isomerize. Okay, so number of isomerizable double bonds is 0. Okay, so in that case then n plus m is 2. 2 to the 2 is equal to 4. So that's the answer that you go in the little box down there. So if you want to pause and write this down, look through it, go ahead. I'm gonna go ahead and erase it and do the R and S. Because the other thing that you were asked to do was to assign R and S to the chiral centers. We've got 2 of them, so that gives you a little bit of work to do. Let's take the top one first. Okay, so 2 bonds are shown in the plane of the board, 1 bond is sticking out at you. That means there's a hydrogen back. Okay, so assign priority. Well, we've got nitrogen, carbon, carbon, hydrogen. So nitrogen is 1, hydrogen is 4. The 2 carbons tie in atomic weight, so you keep going. Don't stop at the first atom. This carbon is bonded to an oxygen, a carbon, and a hydrogen. What do you do with this? It's an sp2 carbon. Well, the rule there is you count both of these bonds as if they're 2 different groups. So this carbon is bonded to carbon, carbon, and carbon. C, C, and C. Well, the oxygen wins, so that's 2, and that's 3. Okay. Fortunately, you've got your priority 4 group back, and so you can just trace your circle, 1 to 2 to 3. All right. That is a counterclockwise circle. So that chiral center is S. Okay, replay that if you need to, but you go 1 to 2 to 3. The priority 4 group is back. Priority 4 group being back is the definition of how you've got to set this up. So 1 to 2 to 3 is counterclockwise with the priority 4 group back. That's S. Counterclockwise is S. All right, so again, I'm going to erase this and move on to do the next chiral center. So you can watch it again, come by and ask questions if you have any. Tidy up the old molecule here. And I'll just redraw that methyl. Don't need that H anymore. All right. Probably faster just to erase it all and start over. All right. So, chiral center on the bottom, two bonds in the plane of the board, an oxygen going back. That means you have a hydrogen sticking out at you. Go ahead and assign priorities. Oxygen, hydrogen, carbon, and carbon. The 2 carbons tie. Oxygen beats everything. Hydrogen loses to everything. So oxygen is 1, hydrogen is 4. Carbon and carbon tie. Now go to your, what are the next atoms? This carbon is bonded to carbon, carbon, carbon. This atom is bonded to nitrogen, carbon, and hydrogen. Nitrogen is the heaviest element present, so the nitrogen beats the carbon. This is 2, and this is 3. Okay, so now I think this top chiral center that I did first is the easiest kind of chiral center to do, because the priority 4 group is away from you already. It's set up exactly as the Conning-Gold Prelog description requires. So you can just do the 1, 2, 3 and that. This is the second easiest. The priority 4 group is pointed at you. So you're exactly backwards of what you need to be. I like to just then draw the circle, 1 to 2 to 3. All right, that's a clockwise circle, which would suggest S, but you're backwards. You're precisely backwards. So if you look at a clock from the opposite side, it's moving counterclockwise. So if this is moving clockwise, then the arrow really should be counterclockwise, and it would be S. Likewise, you can imagine turning the whole molecule. So imagine doing that. Let's draw, let's look down the carbon-hydrogen bond, but let's turn the molecule around. So there's the carbon. If we turn the whole molecule, this one stays up on top, so that's 2. If we turn it, 1 comes around to this side, 3, as we turn it, will come around to the left. All right, 1 to 2 to 3, and now that's a counterclockwise circle. So that's having to turn the molecule, right? And if I turn the molecule, this arrow turns and clockwise becomes counterclockwise. So the second chiral center is also S. Both of those chiral centers are S. Okay, so you have a couple of options then for drawing the enantiomer. One is to draw the molecule exactly the same. So let's do that. You don't actually have to draw those wedges and dashes. If there are 2 groups, if the atom is not chiral, you can just draw lines there. But I think for now it's probably best to keep it that way. We need to put a nitrogen and an oxygen in, and you've got to flip those. So this oxygen is back in the enantiomer, it would come out. The nitrogen that's pointed out toward you would go back. And don't forget the bromine. You can't drop the bromine off and have the enantiomer. Okay, so in 2 dimensions, that molecule overlays perfectly. Both of them fit this general structure. Okay, so they overlap perfectly, and you've just inverted both chiral centers. You could also then imagine using this line in the box as a mirror plane. Let's see if I can actually do that. So there I've actually drawn the mirror image. Okay, if I've done this right, both of the structures in blue will be the same, right? So if I took this molecule and I flipped it over, the nitrogen would go back, the oxygen would come out, and this would overlap perfectly with that. Okay, so that's problem number one. I think that gets everything on problem number one. You always want to read these carefully. Right, that gets everything on number one. I'll do number 2 and 3 in a separate video.